So we spoke about the possible link between sunspots and climate over longer periods of time. Here we can see a similar graph to what we saw before, going again from the 1600s all the way to today, showing the sunspot cycles. The disks again of the sun around the side are shown by these orange dots we can see in this last cycle, showing going from the sun, which is very smooth and flat, the surface with no storms, to the period where we have many more storms. But what I want to talk about again is this gap here called the Maunder minimum. This is, again, a more than 50-year period where there were no sunspots seen on the sun, and we had observations. I should also point out that when we do have a lot of activity on the sun, this is where we have lots of occurrences of the northern lights, the aurora borealis and the aurora australis in the southern hemisphere, because when we have a very active sun, we have lots of particles which are coming out with these solar flares and other storms which make it to the Earth, and our Earth's magnetic field takes these particles into the north and south poles, where they collide with air molecules and give us the light which we call the northern lights. So we've had measurements on the ground in Scandinavia, in Canada, all over the world of the northern lights, again, for centuries. And we can see that by these little green crosses you can see on the plot here. And during the Maunder minimum, there were also people outside looking for the aurora, and we can see the little green crosses here, which are basically at zero. So they didn't see the aurora for about 50 years, and there were measurements. So this is not some problem of the observations. If the sun was active and we had sunspots, we would have seen aurora. So this is something real that happened for more than 50 years, a very weak sun and basically no sunspots. And it turns out that this was also a period that we call the Little Ice Age. The Little Ice Age because there's evidence from many places around the world, mainly in Europe really, and we get this evidence, for example, from paintings, that the temperature was much colder than normal, and that even in the summers we had very cold temperatures. You can see some paintings here from Holland, from Venice, and even the Thames, which was frozen. People could ice skate on the Thames in London, and we have canals in Holland which were frozen, the lagoon in Venice. So we have actual evidence from paintings that in the 17th century the climate was much colder, and people link this maybe to the Maunder minimum. We also have statistical links with many other parameters, and here you can see a plot of the flow in the Mississippi River in the United States from 1840 onwards, and they've been measuring the flow for many generations. And here too we can see that there's some link between the solar cycle, which we can see here in red, and the flow of the Mississippi, which we see in blue. It's not perfect, but there appears to be an 11-year cycle of the flow of the Mississippi River. Now, these are statistical connections. We don't really know physically how did the sun's small changes of 0.1% affect the rainfall, which may have affected the flow in the Mississippi River. But as I mentioned again, there are many statistical connections that people show between the solar cycle and climate parameters on the Earth. This is an interesting one, which also has no explanation, which is actually looking at the length of the solar cycle. So, as I mentioned, the average length is 11 years. But here we can see that it goes from, and the scale here is reversed, goes from about 10 years to maybe 12 years, the time between the peaks. And if you plot that over time, it appears to match fairly nicely with the Earth's temperature in the 20th century. But how is the length of the solar cycle linked to temperature? Nobody has an explanation. And some other connections with, and this is mainly done by people who are somewhat deniers of global warming. They want to show that this is a natural global warming, so maybe we can link it to the sun. And here we can see again the sunspot number on the top and the global mean sea surface temperature. So these are temperatures of the ocean. And when you smooth the data enough, you can see that the red curve and the blue curve seem to match each other fairly nicely. But when you look in detail, you can see that this peak in the sunspot number doesn't really match with the temperatures, and you have other features here which aren't well matched. But nevertheless, statistically, these two parameters seem to be linked. They may be also impacted by a third parameter. But when we start to bring in the more recent data for the last 50, 60 years, we can see here, and basically this is the bottom line of the link with the solar cycle. The red curve shows you the global temperatures, which have been going up over the 20th century and keep on going up, and we're now at least more than 1 degree warmer than the pre-industrial period. And the the solar irradiance, the amount of energy coming out in watts per square meter from the sun, which we can measure, we can see in the yellow curve. And the thin yellow curve shows you the solar cycle, shows you that 11-year cycle. But when you smooth that and get rid of that 11 years, you see that actually the solar cycle and the sun is actually getting weaker over the end of the 20th century until today, but the temperatures keep on going up. So it's possible that the beginning of the 20th century, and most of the scientists will agree to this, that the small warming we saw in the beginning of the 20th century may be mainly due to the solar activity. But from the 1950s and 60s, it's clear that there's a divergence in these two plots and that the temperature keeps on going up. And if it wasn't for other factors that we'll talk about during the course, we should have actually seen the temperature going down and cooling somewhat. Now, if we look again at the long term, what's going to happen with the sun in the future? We've spoken about cycles of 80 years, 180 years. And here we can see that we're now going into we're in the 25th cycle. We're not really sure how many sunspots will be there at the peak, and we're not sure what will be in the next solar cycle. But as you can see, it looks like we're on a downward turn. As I just showed in the previous one, based only on the solar radiation, we should be cooling at the moment. And it's not sure what will happen with the sun in the future. But here we can see the data for the last 3 solar cycles. So the cycle 22, 23, 24, which has now ended. And again, we can see that each one is slightly weaker than the previous one. The jagged line represents the actual data, and the smooth line is a model prediction going through the data and predicting what may happen in the next coming years. But there's one interesting thing that we see. We can look at patterns of the solar cycles, and when we look back in time, the blue curve here was the patterns we saw during a period that we call the Dalton minimum, where we also saw a decrease in the amplitude of the solar cycles over time. We have this Dalton minimum here from 1797 to 1820, for example, and the green curve is what's happening today. And we can see here the scale is on the top from 1988 to 2028, because we're talking about the future as well. But there appears also that the sun is following this pattern which we saw a few hundred years ago, and maybe we can then compare the climate then to the climate today. And if we put this on a larger time scale, we can see that the sun has gone through different periods where it's been more active, shown in red here, implying more radiation coming out and maybe more warming of the Earth. And we've had weaker periods, including the Dalton minimum, which we can see here, which I just spoke about, but also the Maunder minimum. And maybe we're going now into another Dalton minimum or even a Maunder minimum where we'll have weaker solar activity. And so some say maybe this will offset global warming. Maybe the sun is actually helping us, getting slightly weaker, and we don't have to worry too much about global warming. Well, when we take the climate models and we try to predict what may happen in the future, we can see here simulation. First of all, the observations, the black line until more or less today. And then we can see what will happen in the future with the increase in greenhouse gases, changes in the sun, etc., shown by the orange curve with the current levels of the sun. And then we can assume what will happen if we have everything that remains the same with the greenhouse gases activities, but the sun goes into, say, a Maunder minimum. And that's the blue curve here. And basically the bottom line is that there's not much difference. We may have a slight cooling, but the effect of greenhouse gas today is much more powerful than any slight decrease in the intensity of the sun or going into a Maunder minimum. So we can't use this as an excuse to wait. If we do go into a Maunder minimum or something similar in the next decades, it'll maybe affect just 0.1, 0.2 degrees, but we're still going to see global warming continue.